Okay, will do. Okay. Welcome to today's short course where we will discuss life cycle assessment toolkit, and we're going to have Dr. John Lascala do the introduction. Dr. Lascala is the program manager for the systems and platforms at SERDP. He has over 25 years of experience in environmentally friendly materials, over 100 open literature publications, and has been the recipient of universal awards, including being inducted as a fellow of the National Academy of Inventors in 2018. So also co-recipient of the 2013 Presidential Green Chemistry Challenge Award for sets. And, in 2011, received Secretary of Defense Environmental Excellence in Weapon System Acquisition, and 2010 ESTCP Weapon Platform Project of the Year. He has a PhD in chemical engineering from the University of Delaware. I'm Dr. Lascala.
Thank you, Mike. Appreciate the introduction. Okay, so good afternoon, everyone. Why are we here? So we're here to do life cycle analysis. I think this is a really critical thing that we do, that a lot of technical PIs, a lot of us come from a technical background, PhD or engineering science degrees, and we work in developing innovation. And we take ideas and we technically figure out the next sort of steps to advance a technology, to move it in this direction, to take something from that's technology over here in left field and bring it over to right field and make some innovation that way. And that's fantastic. It's very useful. It's a great thing that we do. The problem is, you know, at some point need to convince someone to actually utilize this technology. And how do you do that? Because, you know, what if the technology costs more? What if the technology has a few issues associated with that? And if you look at the valley of death associated with technologies, there's a number of reasons why we have a valley of death. One of it is that it simply just costs more per pound. And whoever you're trying to convince says, I don't want to do that. That costs me money. I can't afford that increase. But you might say, well, you know, in 10 years, you're going to save maybe $1 million over that time period because of this, that, and the other thing. Certain aspects may be due to environmental benefits. You need to quantify that. And you say, well, they'll say to you, okay, how do you get that analysis? If you do good life cycle analysis, that's how you get that. That's how you can figure out, here are some cost advantages of your technology over the years. And that's one such thing. There's other areas of a particular importance from valley of death perspective. A really important aspect is that, unfortunately, inertia and reputation are both generally not in favor of technologies. Most people look at green technologies or sustainable technologies as their instant viewpoint, whether true or not, tends to be inferior to the incumbent technology. That is the psychology of the situation. So they're automatically thinking the performance is going to reduce. So they want something beneficial for this. And if there's an environmental regulation there, okay, you know, we have to change, you know, okay, maybe that's a little easier in terms of things. They're forced to, they need to make that switch. The discussion from Jerry back on the AFFF alternatives, that was, we had a United States law that basically said we don't use AFFF anymore, so we use the next best alternative. That was one of those cases we made that switch. We didn't have to worry about the technology being quite exactly as good, but we still did a life cycle analysis, and that was still critically important because it really shows that what the costs are going to be over the next number of years associated with these technologies, how we can save some money in various areas that we don't necessarily think about. Wastewater treatment is a key area of that. That we would get some benefits with this technology. There will be some negatives in terms of the cost as well, but the cost rate FFF is actually skyrocketing right now because it's hard to get. That is some additional benefits that we didn't even predict. But these are the things that we need to be able to do. I kind of talked about this a little bit, but I'll just make this mention again. In movies, you've heard it, the various movies. If you build it, they will come. There was that movie with Kevin Costner years ago, and as well too, actually. And I think that's great fiction. Is what that is. It's great fiction. It is not generally truth. You can build it and look at it, but they don't know, is this going to meet all these other non-technical requirements that we don't tend to think about as technical PIs within the WP program and those scientific programs. So you got to expand that viewpoint if you're going to change people's points of view, and that's PMs, that's companies, and all these things are important. The companies look at this technology. We have a great way of companies do things great in some ways not so great. I think this is one where the companies really generally tend to integrate a business case and business managers along with product developers. So it's not just, well, here's the technology development alone. They start working on an entire business case of how to make this technology economical, how to sell it to various people. And we do generally none of that. We kind of, state some words, it's going to be a little bit better in this way, or the environmental benefit will be there. That's great. It's environmentally beneficial, but what's my requirement to make that change? And if there isn't one, it becomes crickets really fast in the room. So, so these are all the things of why we are here. And Mike Buckner and his team, and various speakers here are going to be talking about basically ways to utilize life cycle analysis and to do a life cycle analysis and give you tools to enable you to do that in a more effective way. As well as be various contacts that you can contact, work with, you can pay, you can do whatever to help you with a life cycle analysis. It's very important to do. And it's not just important to do at the ESTCP level when you have a product that is ready for transition to actual use. We demonstrated and validated, and now it's PMs, you go in and take it. At the SERDP level, it's important too, because we've got to make that decision of whether it's worthwhile to demonstrate and validate it. And it's not necessarily worthwhile if there is no business case that supports its transition. Yeah, it's environmentally friendly, but it's actually going to use it because, again, there's no environmental regulation, or the environmental costs are not quantified, or they're going to be very small compared to the increase in cost. That's a reason to not do the technology. Let's not waste our dollars on that. Let's spend our dollars where it matters, where we're going to actually make some significant improvements. So again, that is the purpose of today, is to really help us define these life cycle analyses, to make them useful to our technology to help transition those forward. So with that, I'm going to turn it back over to Mike. Thank you. Thanks to you.
So I wanted to start today by providing a little bit of context in addition to what Dr. Lascala already shared, is that the Defense Department's mission is to provide military forces needed to deter and win wars and protect the security of our country and our allies. I think many of us here in this room today in support of this mission, and to make sure we can do so more sustainably. Executive Order 1457, also known as the Sustainability Executive Order, directs agencies to transform how we build, buy, and manage electricity, vehicles, buildings, and other operations to be clean and sustainable. Our weapon systems and platforms program is a key component of advancing this national defense mission, ensuring that the department's operations are clean and sustainable. This short course Life Cycle Assessment Toolkit, with a keynote by Mr. David Asiero, who provided us with an overview of sustainability policies and requirements of DoD, a description of ongoing initiatives, and how this work advances the national defense mission. We will then transition to Dr. Andrew Peterson, who will describe what sustainability analysis and life cycle assessment are and how they are applied in the defense sector. Ms. Emma Williams will then provide an interactive demonstration of the life cycle analysis toolkit for startup and ESTCP principal investigators. This online toolkit's available data, tools, guidance documents, and other resources will be presented. We are eager to get your feedback and thoughts on what's discussed today. And then finally, Dr. Andrew Henderson and I will lead some interactive exercises that demonstrate how PIs can develop their own life cycle assessments. This should be fun. We'll transition now to Mr. David Asiero, who's the Director for Sustainability and Acquisition in the Office of Assistant Secretary of Defense for Energy, Installations, and Environment. He leads technical and policy support teams, and his areas of responsibility include overseeing DoD environmental technology programs, development and implementation of the DoD sustainability, sustainable procurement policy, and maximizing the use of green products at DoD installations, and integrating environment, safety, and occupational health considerations into weapon systems acquisition programs. Mr. Asiero has been with the Office of the Secretary of Defense since 2000. Prior to OSD, David held a number of logistics operations and maintenance and environmental positions for the Chief of Naval Operations and for the Commander of Naval Air Systems Command. Mr. Asiero received a Bachelor of Science degree in Aerospace Engineering from Auburn University, his MBA from Vermont University, and is a 2003 graduate of the National Defense University with a Master of Science degree in National Resource Strategy. It's my pleasure to welcome Mr. David Asiero. Great. Well, thanks very much, Michael. It's a pleasure for me to be here today to speak to you about kind of a concept. It's really not a concept. It should be ingrained in what we do as a business operations, as an entity, as a defense department, as an agency, as a corporation. How do we look at us? It's about sustainability and the life cycle analysis and sustainability analysis, which is what most of you are here to talk about. But I thought to put it in the context of what we do, it's a part of the sustainability and is imperative to our mission. So, all right. I will just use that. But anyway, like Michael said, I've been with LSD for quite a while. I will set the stage here a little bit. Sustainability is about some applications for the sustainability analysis, and then the conclusion, which hopefully wrap it up. This should be interesting. I hope help you with your researchers with your projects as you go forward, because as John said, it's a valley of death, and if we don't have the data to demonstrate to those folks that we're trying to help us implement these technologies you're developing, we're not going to get very far. So short course should take you there, and I'm hoping that today. This is important, right? Our CEO, our boss, the Secretary of Defense, if you look at us that way, knows it's important. I mean, he said this is a covering that. You can't read it. Well, I'll read it to you. It says basically, when we operate more sustainably, we become more logistically agile and ready to respond to crises. I don't know if you at the plenary and Major General Jenkins talk about the logistics and the importance of logistics. the spear constantly as warfighters, but really it's logistics to being agile logistically to make the Defense Department run. Sustainability is a primary method of achieving that. Large companies, the big Fortune 500 companies, are embrace sustainability because they know they're a better business for it. Why can't federal agencies do the same? We're all moving in that direction. So as you go down the path of what you do as technologists or policymakers or whatever field you're in, if you look at sustainability as a business imperative, we're all going to be more successful. So this is important to be agile, and the senior leadership of the Defense Department understands that. It's working. Okay. That's next.
This isn't working.
Okay, now it is. Okay, great. All right, we've got technology that's fine. This is a bunch of fairgrounders here. Now the be able to make this work. Anyway, so why should we be concerned about this? Well, it's about resilience and readiness. We've talked about this a lot at this conference, right? At the plenary, resilience and readiness. Those are the primary effects of the mission. If you look at this vision we've had now since early 2009, we need to maintain the ability to operate in the future without decline, either in the mission or in the natural and man-made systems that support it. So basically, we're saying that the men and women in the military, the artisans and the depots, the folks in the field need to have energy available to them to do what they need to do, which is train and operate today and forever. We've got issues, right? We've probably some of these climate sessions, but there's definitely an emerging change to the climate, which is a crisis impacting us. Not just, our installations, our equipment, our people. And so we've got to realize that if we're sustainable, if we operate in a more efficient and resilient and ready posture, we'll be able to help address that. So what we want to do and need to do is prioritize investments that offer long-term value to resilience, and also look at things like greenhouse gas reductions and environmental preservation. We need to have that environmental preservation component, because without the air, water, energy that we need to do our mission, we're not going to be able to be sustainable. And because of the department is able to leverage sustainable business practices with the market and with our partners in the industry, we're able to use our very substantial purchasing power to move technology in the right direction. And there are a variety of efforts and initiatives on the way of the department and across the federal agencies that are doing that, looking at things like Buy Clean, looking at our sustainable procurement programs, so we can take your technologies and actually implement them in the field. So that's kind of a key element to this, being resilient and ready. So we talked about this again, no decline in the mission or natural man-made systems that support it. That's really how we operate into the future. But what can we do to sustain the mission readiness through cost-effective acquisition? So when we kind of migrate to the weapons platforms, we need to prevent pollution. We've been doing that for years. Our pollution prevention programs, the Pollution Prevention Act of 1990, whatever it was. But that is a component of the weapons systems, a platform thrust area, but also across all the technology areas is critical. Ensuring product availability. We're seeing more regulations becoming stringent. We're seeing not just domestically, but internationally. So we look at things like REACH, of course, and now we look at things like the phase down of hydrofluorocarbons, and the fact that we don't have the availability of these chemicals in the future. So we have to make sure we're sustainable with our products and the chemicals and materials in those products. HSCs is a good one. Not only is the phase down occurring, companies are getting out of the business because they don't see the market for it. So if we get these kinds of products, if we're more sustainable, using less hazardous chemicals and materials, we'll be able to have that resilience that we're talking about. And with that, have a pretty dangerous job. That impact have them exposed to hazardous chemicals, materials, other things that could affect the health of the fighter. So environmental safety and occupational health, and it's not just the warfighter, it's the environment and the management systems that we don't want to be exposed, because if those are regulated, then we're not going to be able to do what we need to do. So what we need to do is pursue advanced, cost-effective products and technologies through more sustainable and less hazardous solutions to support the mission, which will definitely enhance operational readiness. What I do also highlight is sustainability is across a federal, across a corporation, across a company, across an agency. It's not, shouldn't be pigeonholed in an officer area. When you have a chief sustainability officer, the Honorable Brendan Owens, who does cut across the brand profile, but he goes directly to the Deputy Secretary on all matters. So she can cut across the entire department. So when someone says, oh, that's an environmental thing, or that's an energy thing, or that's whatever, it's not. It's a business imperative. It cuts across all lines of the department. And so that's something that people sometimes don't recognize. And I think that leads to John's case of, hey, the value of debt. So we have a bunch of sustainability initiatives going on. This is just a handful. These are kind of the federal sustainability initiatives that the White House was really key on. We might have seen some of these talks at various sessions at this conference. Gas reduction, climate resilience, the climate adaptation plan, the gas reduction plan we've put out there. Environmental justice is really important to the department. How serve communities. When the civilians outside those installations live in underserved communities, why do that to our people? This administration is fairly focused on CFE and installations, but I think as a department, we look at this as an opportunity to be broader and more strategic in our sustainability initiatives, including integrated solid waste management, zero procurement. And what I really want to talk about here in this workshop, short course is kind of about, is sustainability and acquisition. If you're interested too, we published 2022 sustainability plan, which the White House said that was the best of federal agency plans that were submitted. It's available. It's publicly available. You can provide your website. You just go to, what is it? I think it's sustainability.gov. And to see all the agency plans if you're interested. We did submit a 2023, or we call it 2024 sustainability plan, which will publicly, since the White House is reviewing all agency plans now. The intent is not to release it to the public this year, but then next year, the updated plans will be released. So, I don't know if we're very familiar with the acquisition framework, or we call it the adaptive acquisition framework, which was modified several years ago to look at things like urgent needs, which is basically bringing technology in the field 2 years or less. The middle tier, which is 5 years of rapid prototyping, rapid fielding. Then you have the major capabilities, which is your traditional 20 or 25 year acquisition process. And you've got software, business systems, and just goods and services, or services primarily, which is, I think, something like 51% of our spend is on service contracts. What we try to do is acquisition programs cut across the entire life cycle. So, from design to engineering, testing, deployment, and disposal of these systems. So if you just look at one and you look at across the entire life cycle, we're not going to be effective. And so managing the environment, safety, and occupational health risks and requirements in things like systems engineering, whether it's upfront design of a weapons platform, across test evaluation, RDT product support, which is our sustaining activities, our life cycle sustaining planning. So it looks at the entire operations and maintenance of the system. All of that is considered during assessment. And it's important because if you don't, it's not going to be an accurate assessment. One of the tools that we have in the toolbox is the Sustainability Analysis Guide, which does provide a full description on how to incorporate sustainability considerations into acquisition requirements. Most of the time we do an LCA or something in a program, you have your I guess, internal life cycle costs, which you're expecting and people are kind of familiar with. This looks at the other things, external potential life cycle costs, like the social costs of greenhouse gases in the system. What does that mean, and how can you implement that in an analysis? So this is code that probably you guys have seen. I don't know. I mean, in different forms if you have it. Quick story. So like Michael said, I used to work at our systems company. And I was a logistics intern. They had a cool kind of program where they would hire engineers out of college. I'm an aerospace engineer, so I went to work for Naval Air Systems Command and trained us for 3 years in logistics discipline, so that when a system was being designed, the logisticians that hand in hand with the engineers designing the system, we could talk engineer to engineer. We could explain to them some of the logistics issues that will be faced or could be faced if we don't consider that upfront really in the design, because 60 to 80% of the cost of a weapons platform is in the operations and sustainment of that platform. But it's all this locked in that first RDT. So if you don't design out the problems in the first 20% of the program, you're going to be faced with insurmountable costs to try to modify something. Environmental safety and occupational health is part of that. That's another part of the logistics discipline that if you don't consider those issues, so we have adaptive acquisition framework, standard 2, we have the National Aerospace Standard 411, a variety of requirements that the program managers have to consider so that they don't have cost, schedule, and performance issues affecting the platform. The Sustainability Analysis Guide will add to that in the tool that program managers can use to help them avoid long-term costs. That's what that graphic depicts really is life cycle costs are captured as a function of the acquisition process. And we've got to have technologists, program managers, engineers, sustaining community will all be part of this up front, and if we want to avoid these problems down the road. So how can sustainability analyses help you? Well, John mentioned this value of death. It really does provide data. And data is important because people are as they should look at data as a decision-making opportunity. If they don't have the data, they're going to be interested in some of the things that we provide them. So project awareness and benefits help overcome value death if they have that information. It also provides guidance to support and enable success. So if you're not familiar or don't know how to do something, the Sustainability Analysis Guide will provide that capability for you as technologists or program managers or whatever to make this a process that's easier to do. So like I said, it delivers tools and resources so that your job becomes easier. So if you're interested in things like statements of need, broader agency announcements, or any kind of call for proposal, they ask you to do things like develop a baseline of life cycle framework, or identify of the life cycle inventory, conduct assessment of costs, and the Sustainability Analysis Guide and other life cycle assessments around sustainability can help you to do that. So it's something that in the sort of ESTCP world, we've been pushing or asking to incorporate that and submit a proposal. I don't think it's just for certified ESTCP. It should be across anything you're trying to propose, because whether it's required or not, death is out there. And if you have good data, no matter who you're trying to propose to or work with, they're more inclined to accept your ideas, accept your technology, and work with you. And so I'm going to wrap it up pretty quickly here. Just in summary, I try to paint a quick picture of sustainability and why it's a mission imperative to the department. We talk about resilience, talk about advanced mission capabilities. To be sustainable, like any company would, it's a business paradigm that will make us as a department be much more effective. It does achieve goals of the federal sustainability policy, but it also helps the department achieve our internal goals. It's in our national defense strategy. Climate is, it's a real thing. It's more sustainable, reducing the footprint, greenhouse gas footprint, reducing for certain chemicals and materials does make a difference. So our goals are the federal goals, but they actually are broader. And then we use that data to make the most compelling case in terms of mission productivity and long-term cost performance. Again, these help us avoid the value of death. ESOH, environmental safety and health, and sustainability and acquisition process are critical to ensure, and I mentioned this several times, the chemicals and materials that we maintain our systems, the performance requirements to continue to see costs and risk reductions and ensure there's no decline or minimize the decline, I should say, in the natural man-made system. So we do our part. We're the largest in the federal government, right? We hear that all the time. Our buying power is the biggest in the federal government. Our footprint's the biggest in the federal government. We have the most people in the federal government. The agency, agency in the federal government. So, is looked upon as a leader in the federal government, but not just within the federal government, state governments, local governments, and our industry partners and international. So a sustainability analysis will allow you to incorporate these considerations into acquisition. We're continuing to update it to make it more and more, with the times, as things shift, like right now, greenhouse gas emissions, whether it's disclosure of greenhouse gas and by companies that are providing systems to the department or anything like that, we update the system in this guide. It readies users to respond, like I mentioned, statements of broad agency announcements, other calls for proposals, and provide several resources to help users conduct these analysis. And again, I'll just close here with the some comments. We need to operate more sustainably, become more logistically agile, and ready to respond to crises. So with that, I think I'm done.
Yes, so I think now open up to.
Oh, yeah. If you have any questions or thoughts, yes, ma'am.
So there are 3 programs that, DoD can apply for, get research done. But there aren't any programs to apply for procurement, the RIF program. And I work RSIP with OSD, that's a great program too. But what are your thoughts about creating more programs for procurement and maybe like specifically procurement for environmental or, those kinds of issues?
Yeah, that's a great question. We have some small programs like that. We have one called STED, the Sustainability Technology Evaluation Demonstration Program, which basically takes products from some technologies, not weapons platforms for the most part, but products, and we demonstrate those in the field. So if we're successful, we work with GSA and others to get those into the system. Having resources to help do actual RDT&E on those would be, I think, a great idea that we can consider, and how we could get funding for that would be something that I'd like to try to. That's good. Thank you.
Federal goals and assumption.
So federal goals and advanced submission. Yeah, I think the federal goals and our sustainability goals is how we advance the mission. Personally, trying to get the point across that if we are more sustainable, we can understand that it's a business paradigm across our department, and we're everybody on the same page. It'll advance the mission. It'll cut down all the issues cut down many of the issues that are affecting us. It'll help ensure long-term resilience, availability, operational capabilities. Sustainability, definitely is. It's something that took a while for people to recognize, but they are fast and furious understanding that it is a mission imperative. Thank you. Yes, sir.
From a supply chain perspective, we're still, as I still say, we're still in the supply chain crisis.
Yeah.
Okay. And the big move a couple of years ago sparked new interest to bring manufacturing back to the U.S., reshoring. And studies I've been working on has been more on the efficiency cost side as to why companies move to other than U.S.
Mm-hmm.
And it's also market driven. But if we start seeing these coming back to the U.S., there's still very little studies on the sustainable environmental aspects as to why companies should come back. Would this be beneficial?
Yeah, so we're taking kind of a different approach on this because there's still naysayers when we talk about the environmental benefits of coming back. When we talk about the resilience benefits of domestically manufactured, it's huge because our logistics tail is severely impacted, whether you could look at weather events or issues affecting us, contested logistics, for example, I think was mentioned in the plenary. That's a real thing. And so if we bring that back to the United States, that it shorten the logistics tail, then we will be much more resilient and much more effective as a department. So, specifically, there's not as much tension between the climate community and the military community because they understand it's a resilience thing. If we go down the climate path or the environmental path, there's still some pushback. So if you can show that, which I think we've done a good job in DoD, that this is better for the jobs, better for our people, better for the department's capabilities to bring things back to the United States instead of. And it's more expensive if you look at the life cycle of the disruptions of getting things. I mean, COVID is a perfect example, right? So, I think that's where things are. That's the messaging I think we need to put forward. Thank you. Yeah. I just wanted to add a comment on the onshoring from the life cycle assessment. I was in academic circles. There's been debate about some of the offshoring and the environmental consequences of offshoring, and there's been discussion in academic circles that a lot of the data, environmental data that are available are for United States, European Union, Western countries, and sometimes when offshoring occurs, it may be such that equivalent consequences would, or the equivalent processes would have worse environmental consequences. So that's been an open debate in the life cycle assessment community about data. So it's not a perspective. I just wanted to share that thought. Issues. I mean, I'm assuming that, but I've been to a green company where a lot of those vitamins were not here in the United States, right? From China and manufactured in China, and we bring them back here where they were excavated from the 4 countries in Africa. And so there's a whole supply chain issue around where we're trying to go for the goodness of being more sustainable, but also the issues and how we get there. So it's a balance that we're looking through with our partners, helping with other nations and so I think it's a good point. Okay. Anything else? All right. Well, thank you very much. Can you put up the Andrew's side?
Should be this one.
Right. When I'd like Dr. Andrew Henderson to program, Dr. Andrew Henderson as a professor at the University of Quebec in Montreal. His research combines modeling and spatially explicit data sets to improve models of complex systems. Previously, Dr. Henderson has supported certain SERDP programs, advising on projects ranging from explosives to maintenance of weapon systems. He's an active contributor to the United Nations Environment Program Lifecycle Initiative, and he's co-chaired the Certification Task Force for the Phase 2 of the Global Lifecycle Impact Assessment Method effort. He previously worked for the United States Environmental Protection Agency to build lifecycle impact assessment models and lifecycle assessment capacity. And prior to that, he was a faculty member at the University of Texas, always with the goal of improving models and their relevance to decision making. Dr. Henderson maintains affiliations with Eastern Research Group and is an adjunct professor of environmental sciences at the University of Texas School of Public Health. All right, welcome to the stage, Dr. Henderson.
Good afternoon, all. It's wonderful to be here. Thanks to Dr. Lascala and Mr. Osceola for setting the stage here. I'm going to talk about some of the science behind the LCA portion of this work. And but I want to keep in mind that this is informing a broader argument about sustainability that has to include the business case. So we're going to try to make this interactive. And I think the next slide will yeah, perfect. So if you don't mind, if you're willing to play along here, please scan this or enter the code, and this will allow you to do some real-time questions and answers. I think we would also encourage anybody to just raise your hand and or blurt out answers and questions if you have them as we go along. We want to make this interesting, both during this session, which is a quick little introduction to LCA, and then when Michael and I do an interactive session later to actually do some calculations. All right, great. So we'll start off with the first question, just so we get a sense of who is here. And it's lovely to see so many people. And while this goes, I will share my the latest acronym I've tried to come up with for LCA that's not life cycle assessment. It's leveraging curiosity attitude, leveraging a curiosity attitude. And I want that to be in your minds today, because LCA is about being curious. It's about asking questions. What does this mean for a supplier? What does this mean for downstream impact? And it's really LCA, it's not hard. This is the good news. It's not hard. Some of the modeling that goes into it can be hard, but as a user for a principal investigator, it's basic math. So Michael and his team, others at DoD have created a great toolkit, and we'll talk to you about that so that you have these tools. You can ask questions from that curiosity perspective, and you can then, take advantage of all this information that's out there to try to understand impacts of things that you might be designing. Okay, this is great. Obviously, we didn't know who was coming. There are a lot of others. If anybody wants to, maybe at the break, you could tell us who you are. That's wonderful. We're glad to see a variety, though. This is good. Okay. So, next question. Have you had the opportunity to respond on SOM or BA yet? Hopefully we get mostly yeses here, but good. Nice. Very good. This is turning into a race. This is great, though. Truly. Those of you that have, as we discussed, if you have perspectives from your experience, we'd love to hear how it went. And those of you that haven't, a lot of this information I think will be useful for you when you do that. And hopefully you will be, as Dr. Lascala said, bringing innovations, your ideas to bear on some of these problems is really important. And this is amazing. Exactly tied. Okay. Finally, I think this is our last intro question. Have you done LCA or sustainability? So LCA again is the framework. It's the mindset that has some of the environmental modeling behind it that allows you to ask, what's the impact of this system on human health, on the birds and the bunnies? But the sustainability assessment framework is one that's a little bit broader, brings in cost, but it's very much informed by the life cycle style of thinking, which is asking questions about what causes this? Where does this come from? How much does it cost 10 years from now? And this is great. We have a lot of people who have not done this before. Yeah, both sets of folks, yeses and nos. Please, chime in with your experiences or your questions as we go along. So thank you all for participating. This is more fun than just listening to me. I lied. We have one more, which is if you can type in quickly a word or two or even a sentence, this can help us as we go along. Thank you all very much for participating. Nice. All right, I like the pitfalls question. That's good. And I should have said thank you to Em and others for setting up this interactive tool. This is very helpful. Okay, so I can switch. So a lot of learning how to do it. The communication's a great one. SERDP resources, this is very important. Emma will touch on that. I lost the pitfalls, but that was their challenges. It's good. Okay, great. Disposal, reuse. Thank you all so much. So Michael and Emma, as we go, if we don't cover these, let's make sure we huddle and get to them. Great. Okay, so Dr. Lascala, Mr. Osceola set the stage very nicely for why this is important. Some of this will be quick review. We saw a slide that said this before. Costs happen during operations and sustainment. You lock them in early. I've got some examples here that many of you all are familiar with. These are all, people often say unintended consequences, but we should really say unanticipated, unless there's a Lex Luthor out here. No one is intending to do anything that is harmful to the environment or the warfighter or the communities, but it's really unanticipated. And so being curious, using the LCA perspective can help you avoid those unanticipated consequences. And yeah, you all know all about PFAS lately, but there are other examples of these systems that get locked in, and it costs a lot either to retrofit or to undo some damage. So that's what we're hoping to avoid here is we hope you need to make an environmental case and a business case, and LCA provides the tool for you to use to make the environmental case and combine it with the sustainability assessment guide, and you've got the whole story. So this extends a picture that Mr. Osceola said, where we see where costs get locked in. That blue line happens early. We see where the costs are paid, that gray line, you know, as it's during operation, maybe disposal, you start really paying for a system. We have a dotted line here that could be an alternative system. You want to compare yours to another. But what's really interesting here are these green lines at the end, where after the system is done, it's been retired, it's been disposed of, et cetera, there are still impacts that could happen. And this is where the thinking is so important. This is where you could avoid perhaps a PFAS-like situation. And again, we're going to provide you with the tools so that you could say down the line, I think that this is actually going to be much better than the other one, and therefore it's worth paying for up front. It'll save DoD money, it'll save health costs to the American people, et cetera. So it requires being curious and thinking outside the box. Okay. So we've just talked about the system. You saw this picture earlier. I think you saw earlier, resource extraction. If you can't read it, resource extraction, material processing, component production, manufacturing, operations and sustainment and disposition. From where you all sit, and this is an interesting question for DoD, because people who pay for electricity are different than the people who pay for the healthcare costs online, or different than people that buy a building. Where are you all typically spending money on a system? And you all maybe as perhaps more of the PIs are in this sort of design and operations area, chemicals, water, electricity. Yeah, people. Raw materials, big chemicals. Nice. If it's possible to distribute these back to you all at the end, we'd be happy to do that. I don't know, Emma, if we can. We'll find out. This is good. Okay, still the more popular words: chemicals, labor, water, energy, materials. Yeah. Great, thank you all. So these are the things that you see, but what we don't have up here are you know, extracting raw materials from the ground, or necessarily disposal. You may not pay for disposal. You may not pay for healthcare costs. if someone that you're working with gets sick. So these are the things that we want to think about. Okay. Now we look at this picture again. So LCA in a nutshell. This slide you've seen, the next one I think will hopefully tie it all together. The idea of LCA is you have a system, you draw a box around the system, and you look at all the inputs and outputs to that system. And we saw along the bottom, these are some inputs that are typically important: energy, materials, water, chemicals. But what we don't always think about is what comes out of the system. And these could be emissions from your facility where you're actually taking chemicals and reacting them. You could have emissions if you're not scrubbing the air properly, or you may have wastewater. But you could also have emissions when you're using energy from the local power plant. If they're burning coal, you get particulate matter, and that can come back and you could breathe it in. The local community will breathe it in, et cetera. The wastewater needs to be treated, so there could be chemicals used at a wastewater treatment plant to deal with your waste. Worker health and safety is something that Dr. Shannon Lloyd talked about last year, and I'm involved with her in that work. It's not well captured in LCA, but it's very important. So if you're operating a system and you don't have the correct PPE in place, or the artisans aren't using it properly, you could have healthcare costs down the line. So what LCA does is two things. One is it helps us think of all these emissions, the things coming out of the top of the box. And again, these are not just from your facility, but they could be from upstream and downstream locations. And the second thing that it does is map those to environmental and human health impacts, which we see on the right. So we can quantify the net impact or benefit to resource stability, climate change, human health, and ecosystem quality. And ecosystem quality, we were talking about this a little bit earlier. If you're just trying to argue that the birds and the bunnies need to be protected for their own sake, that may not carry weight. But if you can tie ecosystem quality back to an installation's operational capacity or resilience, then it's a very different argument. And LCA can help you do that. It's not a strong suit of LCA, but it kind of goes in that direction, and you can start to make those connections so that the phosphorus from a wastewater treatment plant causes a harmful algal bloom, which shuts down a training station for a while. These things we can model, and it's great to think about them. So that's LCA in a nutshell. Now, the cool thing about LCA is that all of those steps that we saw along the bottom, from resources to disposal, which we think of as a supply chain kind of running horizontally, each one of those has its own supply chain. I've drawn it here vertically. But anywhere along that supply chain, you can think about sort of another supply chain. And this is LCA's power, is to look at all this. There's a nice mathematical structure to do it. You don't have to do it. We'd be happy to tell you how to do it if you want to, but all that information is there. It's oftentimes at a course level, it's kind of economy scale. It's good for the US. It may not be good for the European economy, but data are there, and you can take a first pass. And that's the great thing about LCA. So the math is not hard. All this information is there, but it's getting you thinking that way that's important. All right. So let's talk about a quick example of what could be done, and some of Michael and his colleagues at Novus have worked on this. So at the Fleet Radio Center Southeast, which is FRCSE, they've got to maintain surfaces, right? They're using machinery out in the wild. There's salt, there's temperature, et cetera. They've got to often strip surface coating, inspect the material, replate it, and send it back out for use. So previously we were using electroplating approach that involved cadmium, which of course has disposal costs, has some healthcare issues. And so we wanted to look at comparing an incumbent cadmium process to a zinc nickel electroplating. That's the short story. There's a nice picture of a similar kind of bath. But the great thing for LCA and the sustainability analysis is that FRCSE could talk to the people with the money about why it'd be good to make this change. And they can make the business case from an environmental perspective and a financial perspective. So if you think about a surface coating, we need to extract raw materials, zinc, cadmium, et cetera. We've got to produce them, we've got to transport them. The artisans have to prepare a surface, so maybe that takes some energy, et cetera. They actually do the plating step down there as we go clockwise around here. It gets used on the landing gear or whatever. And finally, the material is disposed of, which could mean it's stripped off the landing gear, disposed of, or it could wear off in the field. et cetera. And this is the idea of life cycle thinking. We think about all these steps, and then for each one, we try to estimate emissions, and those are all coming into the middle here to do some impact. And again, that translation from emissions to impact is something you don't have to do. The factors that are available to you, and some of the resources we'll talk about, make that translation. But thinking about the emissions is where your expertise, your knowledge of the system is really important. Okay, so once you've done this, you wind up in LCA with a big list of the things you're using. And hopefully you can do this at various stages of the life cycle. So here in this zinc nickel plating line, this is not the cadmium one, this is just zinc nickel. You'd have to do it twice. You can get an estimate. We see some of the input categories that we saw previously: the labor, the chemicals, the electricity. There's disposal here, et cetera, et cetera. And so with the tools that are available, you could go from this level of information to estimating environmental impacts and human health impacts. So I think we have a question here. Yes, we saw, labor, electricity, chemicals, waste. Just curious, which of those, and you probably can't read them now, but just go for any you remember, which of those you think would have the largest contribution to just greenhouse gases? See what the wisdom of the crowd says here. Strong votes for electricity. Nice. So the correct answer doesn't really matter here, but just to think about it together, electricity certainly could be a big contributor. It depends on the grid, depends on where you're situated. I've just moved to the University of Quebec and Montreal, where there's a lot of hydropower. So depending on how you evaluate hydropower, that wouldn't necessarily be the case. Waste management kind of depends how process intensive that could be, what kind of waste you're producing. What was it? Water, wastewater was up there, water. Again, it depends on quantities of volume, how process intensive is it. If you're really having to use some high energy treatment processes to get to some really low levels of contaminants, you could wind up using a lot of electricity there at the wastewater treatment stage. But yeah, electricity is generally a good guess for greenhouse gases. So well done. That's good. Okay, so in general, when you find yourself asking questions like this, what are the benefits of something? How much would this save in long-term medical costs or other costs? How much would it save in hazardous waste? Any sort of question that said it's a business question. Is the trade-off worth it? Is the cost of doing something? Is the health savings? Is the environmental impact worth it? Then you need to be using life cycle thinking, life cycle analysis to do a sustainability analysis. And it's great. This is what the statements of need ask you to do. This is the sort of questions that OSD is asking. So when you find yourself asking these questions, think of the resources that Emma will talk to you about. This is to review. You saw this just a minute ago. There is a guidance document that helps you through this. There's a method. It uncovers hidden costs, and this is great because we're looking for those unanticipated hidden costs that are financial, but also costs that we don't normally think of as costs. Oh, sorry. These slides are available, right? Will be available? Okay, so the slides will be available. The word clouds may not be. We shall see. There we go. One last picture. So for example, so this is good. Mr. Osceola mentioned this before. Direct internal costs, these are the ones that you are most familiar with. They might come out of your pocketbook, your institutional pocketbook. I need to buy these chemicals, et cetera. They're indirect costs. You may not pay for electricity that you use, but someone on the installation does. So that's an indirect cost. Then we have a type of costs that are called contingent, and these are probabilistic. They are sort of anticipated, but not necessarily realized. So cleaning up pollution. If someone had done an LCA of a PFAS and non-PFAS alternative perhaps someone would have said the cleanup costs for PFAS are just too much. Let's use something else. But we mentioned healthcare costs, so there's medical costs. You're certainly not paying for that, but DoD is. And finally, there's the last one that's sort of separated there in the blue are social costs. We heard about the social cost of carbon. There are damages to human health and ecosystem that are not on DoD land, not to DoD personnel, but nonetheless impact DoD sort of through the communities and through the larger impacts in the US. So LCA tries to look at all of these, and sustainability analysis tries to look at all of these. And I think we'll say this a little clearly later, but they're all different kinds of costs. They come from different buckets, and certainly the external costs, the ones that are quantifications of damages to an ecosystem, are not ever necessarily paid for in a sort of formal way. But the impacts are felt. So we don't generally add these together. The two internal costs on the left, the direct and indirect, you could add together. But the other ones, you need to be clear that a probabilistic future cost is not the same as the electricity cost you're paying. All right. We're just going to quickly remind you that this process, because it's so encompassing, brings a lot of uncertainty. These are just notional graphs of probability and sensitivity analyses. But it's really important, again, because you know your systems, to think about where the uncertainty is and try to bring that into your analysis. That requires definitely some creativity on your part. There are a lot of ways to do it. You can just go for low, high, et cetera, et cetera. But it's important to think about that, especially when you're comparing two alternatives, because you don't want a single estimate and a single estimate to be perceived as different when the uncertainty range is perhaps such that you can't tell. And that's an answer too. We can't tell the difference between these two things. Okay, very briefly, Mr. Asiel mentioned the HFCs. So statements of need are asking right now lower GWP alternatives to refrigerants in use. So there is, we need to think long-term. Obviously, HFCs and a substitute need to perform in a similar way, and they each can be emitted, et cetera. But the LCA would ask you to look across the entire life cycle for those GWP alternatives. We have a few other examples that you can read at your leisure, but they all these SO1s have similar language about, do this thing, but do it in a way that reduces costs, reduces environmental costs, that's energy efficient, et cetera. This sort of language shows up, and it's great because it gets you thinking at the design stage about the lock-in costs down the line. So this was advanced coatings. Here's reduction of hazardous waste streams, et cetera, but similar kind of language. We still need to reduce the life cycle costs and impacts. So the tools that Emma will talk about, that we'll talk about also in the interactive session, can help you do that. So you saw this slide already as well. And the important thing to know is that there's expertise all around. You can ask for help, and you should. The toolkit is some place you can get started, but there are folks within DoD, in academia. The EPA Research Lab has been working on this for a long time, and people are really excited to help you with these questions. There's a group called the Federal LCA Commons that brings together, all these agencies, including DoD, to have some standardization of modeling. There's a whole other topic about the potential for sort of disagreement in modeling. But standardizing is great. This is happening, and you should take advantage of it. The DIO that we'll talk about later takes advantage of some of this consistent modeling. So there's guidance available to help you to make these analyses, and we're excited to work through some examples with you. One picture, okay. So data is available. Again, you read this at your own at your leisure. And we just want to know, has anybody looked at any of these? So these are things like the scoring factors that we'll talk about later. The EPA IO models, the UCIO model, data from Argonne or NETL or NREL, et cetera, et cetera. Great. A lot of new resources then for you to digest. Nice. All right, about 3/4, a little more have not yet had the chance to do this. That's good. Okay. Standardized data, this is the DRO that provides the factors that translate purchases in dollars to impacts. We'll talk about that later, but it builds on and standardizes some of this work. Some of the folks in the room are working on updating this right now, so we really appreciate that. And I think we'll leave it at that. So your recommendations are, when you see this language, which you will, please take advantage of the resources that we're talking about today in the toolkit. Please take advantage of the Nobles team or folks in academia or whoever you know that does LCA to give it a shot. And the thinking is the important thing, the curiosity, the interest in where did this come from, where does it go, how much does it cost then, how much does it cost now is really important. So I think that concludes for now. We'll have a break shortly, but are there questions now or later? Okay, we can do questions now. Yes, sir.
Hi, thanks very much for that. It was really interesting. I have maybe a philosophical question or two. You said that you can't take into account probabilistic contingent costs, and you can't add them in with the other costs, but you do probabilistic risk assessments all the time. So that doesn't quite ring true with me. The second part is from the same slide, and that is with the external costs.
Okay.
I mean, we have to address those. You can't just say, well, we can't add them, therefore we can't consider them.
Yeah.
So how do you deal with that?
Thank you for the clarification. That was a pretty good quote. I did say they should not be added, but I didn't mean to say they should not be considered. What I meant to say is that if you develop a system and you want to compare it to the incumbent, and you add all those numbers together, a lot of information gets lost. What I was suggesting is that you could say the incumbent system and the new system have these costs that DoD pays out of pocket now, the direct costs, the indirect costs. And in addition, there are other costs that look like this, that could be probabilistic related to remediation, could be probabilistic related to healthcare. And then there's yet another set, which is ecosystem quality, human health that happens in the larger, the distributed communities, not the DoD. So it's not that shouldn't be considered, but just that we shouldn't add them together because we sort of obscure some information there. So I appreciate that clarification. Does that help?
Yeah.
Yeah. Okay. Great. Great.
Presentation, and I love the subject. Mark Patterson from Naval Facilities Engineering Expeditionary Warfare Center. On March, with basically, with your resources, coming out of the ground, going to manufacturing, and then, as far as wherever the product might be, and then getting the product to where you're going to be plugging it in. I mean, there's in between each one of those, there's transportation, and transportation, as far as the impacts, on transportation. So that's part of LCA too, right?
That is part of the LCA, and part of the tools that are available are a set of scoring factors that we'll talk about later that save you the trouble of doing all that, which is not to say that you shouldn't think about it. But what I mean is, at the level of a PI, if you don't want to get into the supply chain logistics world and figure out all the transport from resource, et cetera, there are factors available that have rolled those together into an overall impact. And that is you'd be using generally appropriate factors for the US, for example. We don't yet have factors for a manufacturing facility in another country. So you could say, all else being equal, here's what this resource, this material, this input requires in the US economy versus another material. And it could be that your particular situation has a slightly different logistics chain, and so there's a slightly longer transport or shorter transport. So we're not asking you to model that, but there are ways to do that if you really got curious about it. So the life cycle thinking, yes, should include the transport, and the factors that will show do, but they're based on US economy averages.
Right. So, materials too that may have low carbon, you're going to have to ship them halfway around the world. You know, I mean, that's
Right.
then adds to the embodied carbon of that product.
Certainly does, and this gets to the case where it illustrates the point of your knowledge of your system. If you're really trying to evaluate, say, an incumbent and a new system that involve massive shipping, you would want to sort of model that explicitly. And that is possible in the database that we'll show you later. You know, obviously, if you're trying to reduce overall carbon footprint, you want to minimize that. But if you're talking about two different incumbents and say they have different weights, then that shipping, even if it's the same distance, could have different footprints on the carbon side.
All right, thank you.
Yeah, great questions. Okay.
Break it.
Really good. Yeah. Yeah.
All right, I want to thank everyone. We'll take so a little more than a 10-minute break. Maybe we'll be back at 3:07.
Oh, I'm not sure if I know who this is.
Yeah, no need to reshare them.
Yeah, I know some.
All right, welcome back, everyone. Now we're going to jump into a demonstration of a Sustainability Analysis Toolkit or Cycle Analysis Toolkit. Ms. Emma Williams is going to walk through the demonstration. Some of the Senior Environmental Engineer at Novus, nonprofit science, technology, and strategy organization with 5 years of experience. Since joining Novus, Ms. Williams has supported the Department of Defense clients by aiding in identification, assessment, and management of emerging chemicals of concern to DoD and conducting sustainability analysis over different weapon systems and platforms. The work includes chemical risk assessment, sustainability, supply chain assessment, chemical material tracking, and life cycle assessment. Ms. Williams holds her MS in environmental policy management from the University of Denver and BS in chemical engineering from Trinity University. All right, I'm on the stage.
Hello, my name is Emma Williams, and I will be presenting a demo of our Sustainability Analysis Toolkit. I'm presenting this on behalf of myself and also Heather DiCaprio, who is the lead. So the purpose of this toolkit is to provide PIs with resources needed to meet their sustainability analysis requirements within their statement of needs. Currently, this toolkit will be available on the SERDP and ESTCP website under tools and training. Currently, it's not up just yet. We have it up on the demo site, but we're expecting to have it up in the next calendar year. And also, as you can kind of see, that there's going to be 8 support pages. This includes introduction to sustainable analysis, guidance documents, training videos, templates, tools, example case studies, additional resources, and FAQs. And I will be going through each of them, each of the pages, and kind of giving an idea of what you can expect in each page. So first, if you go to Introduction to Sustainability Analysis, this will take you to an overview of what a sustainability analysis is, and also kind of describe the 5 steps that are involved, including defining the scope, creating your own life cycle inventory, creating life cycle impacts, and also life cycle cost estimates, and then lastly, synthesizing the results and iterating. And additionally, this page also does include a description of what's contained in also each of the support pages as well. So next, if you move to guidance documents, this will take you to 4 main guidance documents. So the first is a greenhouse gas guidance for the R&D community. So this guidance specifically provides the R&D community with guidance on how to account for emissions by scope. So included is a step-by-step example using a floating line case study, and also the defense input-output scoring factors, which we'll go into. And this will help you guys understand how to account for scope 1, 2, and 3 emissions. Next, we also have included a pure and polyfluoroalkyl substance, or PFAS, characterization factors guidance. And this specifically provides characterization factors for 2 specific PFAS substances, including PFOA and PFAS. This guidance specifically helps to improve the resolution of the ecosystem quality impact category by providing additional ecotox and environmental fate and transport indicators. And in this guidance, we specifically show PIs on how they can take these PFAS characterization factors and how they can actually apply it into their own analyses. Additionally, we also kind of describe how you can interpret the results as well. And additionally, we do include a notional example that kind of shows how you can go through the steps. So next, SERDP and ESTCP funds projects based on different technology readiness levels, or TRLs. And so the specific guidance shows PIs on how they can meet their sustainability analysis requirement based on their TRL, data availability, or any sort of scaling results. So for instance, at an earlier stage TRL, we recommend doing a screening effort, kind of like using hazard assessment to meet your requirements. And then as you go to more of like the later TRL 7 through 9, we recommend conducting a full LCA. And then lastly, we also included a reference to the DoD Sustainability Analysis Guidance, which Mr. Osceola and Dr. Henderson mentioned. So this is another guidance that kind of talks about the methodology for going over LCA and also conducting your own life cycle costing estimates. And it also kind of shows how you can use sustainable analysis to meet your acquisition requirements. So next, we also include training videos. So as you can see, we have 2 available recordings. The first is actually the 3-hour short course that we did last year. So that's currently available. And then we also have an additional video that kind of shows available EPA data and tools to support LCAs. And we're also hopefully getting a recording of this year's LCA short course that we can also include. Next, moving on to tools, we have 2 tools kind of shown. So the first is actually the defense input-output scoring factors. And so this provides midpoint and endpoint impacts and also external cost for each process. So as Dr. Henderson mentioned, we're also going to be exploring and actually using the DIO scoring factors later in the interactive exercises. And then lastly, we also have a document titled Overview of Available Lifecycle Assessment Software and Lifecycle Inventory Databases. So this software kind of describes available resources such as common softwares and data sets that PIs can use. We provide a brief description of what's contained in it, so PIs can determine which ones might be more helpful. And we also include information about associated costs, or whether things have a cost or whether it's free to use. And for templates, we have two different templates shown here. So the first is a report template that specifically just shows where you can include your LCAs or lifecycle costing results in your final report. And then the next one is a data collection template. So this is a Microsoft Excel sheet that kind of provides a data collection template. So you can actually develop your own lifecycle inventory, apply characterization factors or scoring factors to generate different lifecycle impacts, as well as also calculate your lifecycle costing estimates. And then for example case studies, so this tab specifically includes a few fact sheets showing the results of the sustainability analysis that have been previously funded. It's a good way to also kind of show the associated benefits such as waste reduction, emission reduction, all the way to life cycle savings. So this first tab, it kind of shows a fact sheet for a aluminum anodized line alternatives up in the fleet readiness in the Southeast. So if you select on it, it'll kind of show a detail of what's included in the scope of the assessment, what are some of the benefits. And in this specific example, you can kind of see that there was a reduced cost for using the alternative post-treatment. So next, moving on to additional resources. This mostly just contains links to other helpful federal agencies or external resources. So we have links to the federal LCA Commons, which Dr. Henderson previously mentioned. We also have a few links to EPA, DoD, and many other federal agencies. We also have other external resources related to greenhouse gas accounting, life cycle assessment, life cycle costing. And if you specifically click on the next page, this will take you to some of the resources that Mr. Osceola mentioned before. And if you actually scroll down, you'll be able to find the DoD Sustainability Analysis Guidance, the superstructure example, as well as the defense input output scoring factors. So lastly, we did include some frequently asked questions, which as the name sounds, we provided at least some common answers to some of the most common questions we hear from PIs. And we also tried to direct users to some of the most relevant documents and pages. But in terms of next steps, we have completed the current demo site. Like I mentioned, it's not ready just yet since we're in the process of reviewing the content. But whenever the actual toolkit is actually final and ready, then we'll make sure to alert PIs with the LCA requirements, as well as those who just want to conduct their own sustainability analysis. Thank you for your time. This is contact information for Heather DiCaprio, who is the lead for this project, myself, and Dr. John Lascala, and I'll take any sort of questions. Okay. Should be straightforward. Okay. I'm going to share this. Yeah. So much. Yeah.
All right. Thanks so much.
Thanks, Emma. We're going to transition now to the last activity of the day. The Sustainability Analysis Interactive Exercises. So, Dr. Henderson, if you want to come on up. All right, we're going to walk through a number of a little bit of information and get into interactive exercises.
wanna,
I think it's a different code now. Right, okay.
you wanna go ahead and do? Yeah, please.
You can just start. We have a little- Okay. The code is still up at the top, sorry to move ahead, but in general, now that you've had a chance to have a little break, we really appreciate all the short little input, but if anyone has any specific questions before we start, please feel free to type them into the interactive Mentimeter here, or feel free to ask them orally. And this one disappears after the slide goes, right? Okay. Okay, so we'll move on, but please keep questions coming. Ask them as they come to your mind, and we'll deal with them together. Okay. So I think Michael can give us a little bit, another picture of this. I talked about LCA, now we'll talk about combining with the costing for the full sustainability analysis.
Okay.
So what is a sustainability analysis? It's comprised of two items: a life cycle cost estimate, environmental life cycle assessment. And we talked a little bit about each of these pieces. Generally, it's two analyses that are conducted together. And there's the internal costs, the contingent costs, environmental impacts, and then those can be translated to external costs. So these are, I think we've heard this a good deal already. This is just another visual format. Again, the life cycle perspective, we've seen this once already. Life cycle assessment is mathematically a series of inputs and outputs, and what we do is we quantify on the top what the LCA practitioners call elementary flows. So we quantify each one of those releases to the environment or outside of the anthrosphere, the human system. And there's a 5-step process to do a sustainability analysis. We begin by defining the scope. What is the problem that we're looking at, the system, looking at the system boundaries. Oftentimes this involves development of a detailed process flow diagram. There may be iterations. A good practice here is to understand what's inside your facility, what's outside your facility, where are you going to get primary data, where are you going to get background data. You should start thinking about the scope step. Then once you've scoped that out a bit, you get into what we call the life cycle inventory, or basically data inventory. This is where you spend most of your time. This is giving information about whatever process or system you're modeling. You may have direct information about electricity usage. You may need to do estimates about heat losses for the tank that you will need for your process chemicals. You may need to estimate the costs associated with the waste that you're going to dispose. All of this information comes in at the inventory stage. And then we jump into the life cycle impacts and the life cycle costs, and we have them concurrently, even though we call them steps 3 and 4. And we really need that life cycle inventory to then understand the total costs and also the environmental impacts. We then synthesize these results and iterate. And one of the things that we love to do to make things simpler is have those series of arrows at the bottom to demonstrate that this is an area the process, you may start at step one, go to step three, and then go back to step one or go back to step two. It's likely that as you're working on the analysis, you'll need to iterate. Just a little bit more about what's contained in each one of these steps. And these steps are described further in detail in the Sustainability Analysis Guide. So that first step, defining the scope of analysis, begins with a definition of what's called the functional unit. The functional unit is a basis of comparison. So, for example, if you're looking at a plating system, I think was an example given was an equivalent of plating required for a similar performance context on a system. An example of, or if you're looking at a refrigerant, what is an alternative? What is a comparable quantity of refrigerant that produces the same amount of functional output. So these are what we call the functional unit, and oftentimes the lifecycle assessment practitioner will need to work with the domain expert, the engineer scientists who are developing the new technology to come to some kind of agreement as to what this should be. And then also thinking about the system boundaries. Are we looking at what happens in the facility, the primary data? Are we information about the support infrastructure of wastewater facilities to define the transportation networks, what is relevant to this analysis. So all of that's within the scoping. Then you get to the life cycle inventory. This is again where we spend most of our time. This is really the collection and generation of inputs and outputs. And you may be collecting this data, generating this data through engineering calculations or other estimates. And you may use background data as well. And aggregate the elementary flows and internal costs as part of this inventory step. Then we get into lifecycle impacts. And this is where we translate that inventory into environmental human health impacts and the life cycle cost step. This is where we begin to quantify those different buckets of costs. For example, we talked about internal costs, contingent costs. Contingent costs have a probability. So what's the probability associated with a contingent cost, future possible costs, and then synthesizing these results and iterating. And once again, the Sustainability Analysis Guide has more information about each one of these steps. There's a little bit more example, a notional example of data requirements for a system. We have physical data, and I think the earlier example had some of these there. We will need cost information as well. These may not be synonymous. You need to be estimating going on. Sometimes you have cost information, sometimes you have physical information, but you need both of these for the analysis. And then you generate outputs again, which is what we talked about before: environmental releases, emissions, and also the cost outputs. Okay. Now, into the cost estimates, and I think Dr. Henderson talked about this a good deal already, but you'll need to quantify your internal costs. This may include procurement costs, what is your chemicals or electricity costs to buy, the pieces of that, for example, manufacturing. And then also the indirect costs, the water treatment, your air may need to go through a system for cleaning it, et cetera. And then finally, we get to the external costs, the social costs of greenhouse gases, et cetera. There's 4 categories of external costs that are able to be quantified in these life cycle assessments. Okay. And then once we go through that, there's actually a process for the assessment where once we've done the inventory, there's actually 3 steps in the impact assessment. And actually, these are done simultaneously with the scoring factors that we'll walk through today, but there's a number of very detailed midpoint impacts, and we'll show examples of those midpoint impacts. And there's endpoint impacts, like impacts to the ecosystem or social cost or greenhouse gas emissions. And then there's rating, which is how can you decide on the relative importance of all of these outputs. Now we have shown here the defense input output tool, which is actually the tool that helps you do the last step that we talked about. The DIO supports estimates of supply chain emissions, and it does use defense specific information. And I think Dr. Henderson went through it a bit quickly earlier, but in this model, there's information from across the United States economy. It's built off of EPA's United States Environmental Extended Input Output Model, UCIO model. It's built off of that as a base using the United States Federal Framework for SER modeling, and includes further defense-specific information to help you model. And then again, the impacts can be rolled up at midpoint, endpoint, and evaluation levels, which is what we were talking about before. You can use either spend or mass information to actually generate the estimates, and we will do examples of this. You can find information on this there. And we're also, if you're really interested in learning about the background information in this model, we did recently complete a sort of ESTCP 3-year effort on improving the defense input output tool, and there is actually a final ESTCP report on DIO, so we can share that with you if you'd like more information on DIO. Okay, the last step, once you've done all this, is to synthesize the results. This is to display the results in a way that is important for your community, or business or whatever may be. On the left, you'll see an example of life cycle costs. They have those costs broken down by life cycle stage. On the right, we have an example of the external costs, and this is demonstrating that Andrew was talking about considering these, but not necessarily adding them together. So this is an example of how you can do that, quantify internal costs, external costs, and demonstrate them. Again, these are notional examples, and that's why they don't have the axes or values on the axes, we'll say. So now we'll jump into a few examples. We've done a number, there's been a number of applications across the Defense Department of life cycle assessment. Here are a few examples displayed. I think Emma talked earlier about plating examples. Some of the Navy have done analyses of LED lighting versus more traditional lighting. There's been a number of studies on additive manufacturing, backup power scenarios at Fort Hood, different engine designs and the consequences of emissions of different engine designs on the TAGS naval vessel, sustainable alternatives to C4 demolition brick, and Dr. Escala talked before about PFAS-free alternative firefighting foam example. So there's been a lot of application of this methodology in different domains within the Defense Department, and I'll pass it over to Andrew to talk about this example.
Thank you so much, Michael, and thanks everyone for coming back. So this is an example that I actually worked on when I was supporting serving ESTCP. So the question here, there's always a question, what's the benefit? Is it worth it? The question here is to maintain helicopter rotors. There are a variety of ways that we could do that. There was a particular process that a variety of depots were using. And the question was, is it better, and the process was called Tagnite, is it better to have the process at each different maintenance depot, or is it better to ship the rotors to one depot where the process is applied and then ship them back? And so this sort of gets to your question about transportation. This was particularly a transportation question. Is it worth shipping them around or not? And so on the left here, we kind of have the boundary conditions, and Michael talked about the scope. What is the question? And then the question I just said is it worth shipping them to the locations? If we use them all in one location, we have fewer tanks, we have perhaps a little bit less disposal of hazardous waste, but now we have all this extra shipping involved, and that costs time and money, and it has greenhouse gas emissions and particulates, et cetera. So on the left is the boundary where we can say, transport on the left there, stripping, et cetera, and then transport it back. At the top, it's always good to say what's not in scope. What's not in scope here is aircraft disassembly, inspection, and reassembly. So that's not part of the scope. Presumably, in the two different scenarios, that would be the same. So then step 2 is kind of a way to show the DIO on the left, where we have all the supply chain pieces. These are the things that we buy. And Michael, thanks for clarifying that the DIO is defense specific. The UCIO, US EEO, is the US economy. The DIO takes that and adds some defense specific processes like transport. What else is there? Aircraft, right, use of aircraft, and more. Ms. Williams and others are working on that right now. So, and then on the right-hand side, we often split these into the background and the foreground. The foreground is where the process engineers understand well. This is the heating of the tanks. This is the disposal of certain quantities of chemical, et cetera. So the DIO, again, we'll see how this works. It gives us some of the background information, but we model, Michael also said, you can model spend or you can model actual quantities. So we did both here. So we have systems, and then we can bring this all into a cost framework. And so the costing, we haven't talked a lot about that. We said the word cost, but everything I've been speaking about has been environmental. And we'll see these scoring factors. They take you all the way to that external cost, but the scoring factors don't provide you your direct, et cetera, costs. So we'll see how that works. So anyhow, we get the cost from the LCC. So these are on the left, or rather the middle of the costing portion. We get the indirect costs, we get the direct costs. In this case, we didn't include any contingent costs in the future remediation because we decided that was probably not relevant in comparing these alternatives. And then on the right-hand side, we get a change in climate for a couple of different scenarios. And it's not terribly important, but these are, how many depots are doing this and how frequently do they ship it? Is it by air? Is it by truck, et cetera? So that's really neat because, again, it provides, in this case, a maintenance group with the information to make a decision that saves them money in the long term and saves some greenhouse gases. Okay. We are now ready to try something that has never been tried before. No. Actually, I think, I did something along this line last year, but when I teach undergraduate students, I have a fair amount of leverage. In this case, I have no leverage over you. And if you were undergraduates, I would ask you now to talk. And I really mean this. I think if you can talk to one another a little bit, this will make the session much more lively for you and for us as well. So what I would like to suggest is that we're going to try to kind of walk through a few topics, or sorry, a few of the stages here. Look at the inventory, and then we'll put it into the spreadsheet and you can work along with us. But first, let's think about some topics. So you can do this individually. A question, yes, sir.
Can you share the code again?
We'll share the
METI code.
Oh, the METI code.
We just.
Oh, it is gone. Well, actually, in this case, we were just going to do this.
Oh, okay.
I'm sorry. Thank you. This is just now we're really in person. So for those of you watching this in the future, apologies, but you're not here anyhow. So would you if you can, you can talk to one of your neighbors, you can introduce yourself to neighbors you don't know, you can talk to a colleague that you do know. But let's see if you can think of topics that you're working on, and we can turn it into a little interactive session here. In the end, what we put into the Excel is going to be a bit of Frankenstein. Maybe we'll have a process submission from this table and a purchase from that table. It'll be completely meaningless, but you'll get to see how it works. So just for a minute, you can think about a topic, a question. Is it worth doing this? My system versus that system, or I've been thinking about this. So would you be willing to think about that just for a minute? Maybe talk about it with again, a colleague or a new friend, and then we'll just share them out loud and we'll kind of see how this goes. So again, I have no leverage over you. You can walk out of the room if you want, but it would be interesting if you can just maybe for a minute or two, just talk. See if you can think of a question that would be addressed by sustainability analysis. So much. So what I had a chance to share some ideas, and hopefully, another benefit here is that you've met someone who's working on something that's related or knows someone that you need to know. So hopefully there's a little networking happening here. But could we quickly go down and just one person from the table just shout out kind of the question that you're asking? It doesn't have to be representative of everything you talked about. But let's try that just so we can all start to think about the variety of questions here. So since you are first, I guess we didn't.
So one of the questions is in developing fast-free fire suppressants, you typically machine fire truck delivers the flame certainly. All this applies to PFAS-free foams. Another machine that we've been doing research on is called compressed air foam. It injects air into foam solution differently, and as a result, you have less foam required, and so on.
Excellent. Great. So that perfect kind of sustainability question. We've got two different systems, both doing the same thing, but maybe one requires retrofitting trucks, one doesn't. We've got different quantities. Fantastic question. Okay, Maya, thank you so much for facilitating this. Anybody from that table?
One of the things I'm interested in is how do we compare biomanufacturing chemicals to actually producing them via chemical processes, as well as how do we account for hybrid processes where both of those are occurring, and maybe new methodologies for synthesis of materials.
Fantastic. So we can kind of make this an exercise here. I didn't say it specifically, but the functional unit for the first thing is some amount of firefighting foam to achieve some sort of spec performance. In your case, you're looking at synthesizing chemicals that presumably are identical at the end of the day, roughly. Some cases, okay. So we need two different methods for synthesizing the same chemical. It doesn't really matter what they're used for, but we're interested in the synthesis piece. So that's a good one. This is a case where the chemist would understand, or the biologist would understand the processes very well. You wouldn't be relying too much on the sort of national averages of anything. You'd be putting in a lot of specific data for your processes, but you have to buy reagents, et cetera. Great. Next table, please.
Ours was similar to table 1 on the PFAS replacements, but it was more focused on comparing the generation of the free chemicals, how they're manufactured and compared to the PFAS.
Got it. Okay. So in that case, so the scope, the functional unit, you're trying to produce chemicals that are, in this case, different with similar function, and you have to make sure we understand how many of chemical A you need to achieve the function versus how many of chemical B. And then you're also looking at the synthesis methods. Great.
Shaquille and I talked about it's actually related to a project. So my engineers are working, replacing different motors and components and looking at the obviously correlates should be if it's hazardous, but is that issues with protect life cycle becomes shorter for aircraft if we use a different coatings of that nature.
Excellent question. Great. Yeah, we've got an alternative coating. We understand it doesn't last as long as the incumbent, but it's less toxic in some aspects. So where's the big point? How sure can the lifespan be? It's for it to make sense environmentally and of course cost wise. If we're stripping and playing all the time, the cost is going to come back and get us. Great. I love the variety. This is fantastic.
Okay, this started as a software question and morphed into 3D printing of rotor components versus traditional casting or however it is that they're.
Okay, great. We're making now we're into the physical realm. We're making these structural elements, and we need to make sure they're performing similarly. We need to understand how they're manufactured, what's their lifespan, what are the different costs. Yeah, wonderful.
I wanted to add one there that one of the things that's interesting in the additive manufacturing realm is also throughput considerations because volume of generation matters too. So I just wanted to add.
Yeah, wonderful.
Yeah, also along the additive manufacturing route, basically comparing the repair of aerospace material as opposed to replacing it. The repair will be lower quality and take longer, but
right. Uses less material. Yeah. Okay, good. So that's a good one. Do we repair? Do we replace? These are great examples. I really wish we had time to do all of them. We'll see how this goes as we go forward. This is as I said, never been done before. Any other questions or comments about any of those?
We should move on.
We should move on. All right. That's why I'm the academic. Okay. So.
A question back here.
Yes.
I'm going back to your other example with the zinc nickel versus cadmium.
Yes.
Okay, we could probably figure out what zinc nickel costs. We could probably figure out what cadmium costs and disposal costs, things like that. But can we somehow tie it to a human factor? Like, it's safer, but can we quantify that safety, if you will?
Well, we claim to, yes. So there are two answers to human. One is the the folks who are actually using the material. LCA does not yet do a very good job of that. As I mentioned, that's in process right now and eventually will be added to the DIO, but no one has done it yet in life cycle assessment. That doesn't mean it hasn't been done. And certainly you could do a risk analysis of your particular facility and have a good sense of what's the dermal contact, is there inhalation? You could do that, and that would probably be a wise thing to do. When you know your system, you should analyze it as well as you can. So yes, in the future, that'll be available as sort of generic economic sector level. But it's always good to model it close up. That's a great question.
But the counterpoint on that is if there's a societal effect of the environmental aspect.
Yes, thank you. Sorry. Thank you, John. Yes. In the case that the cadmium or the zinc or whatever substance you're talking about is not disposed of properly, if you got stack emissions or the wastewater is not being treated, LCA does allow you to estimate human health impact and ecosystem impact at a sort of a distributed scale. So we're not talking about workers, we're just talking globally. Who people next to the installation, people could be hundreds of miles away, depending on the pollutant.
I think we're talking about occupational exposure versus emissions to the environment. So LCA does help you, the human health estimates from emissions to the environment.
To the environment, yeah. You could call it near field, far field, yeah. Great, good clarifications. Okay. So we've had some examples here, and maybe in the interest of time, let's see if we could think about some of the emission, the inputs and the emissions, and I think this is clean enough that maybe we could do that since you've seen all these words before. The scope here has been drawn around the entire system. So for what is a PFAS replacement, an aerospace repair, testing my memory here. Yes, the other examples. This is what we're concerned about. And so even though we're drawing the entire supply chain here, the examples we talked about, we're talking about resource extraction, but we understand that that's embedded in the question. So the things that are going into this, we're always going to have energy. So electricity, heat. Let them do it. Yeah. Okay. All right. We're going to let the audience call other things. For the examples given or things that you talked about. So inputs to the system, what do you have to buy? Generally, what do you have to buy? What do you have to take out of the rake? That's a gimme. What do you have to take out of the air? Are there inputs to your systems? So please just call them out. I don't think we need microphones. I'll just repeat them here.
Raw materials.
Raw materials. Yep.
Water.
Labor. Electricity. Equipment. Yeah, great. There's one I don't think I've heard yet that anybody, I think you've all needed some sort of reagent, probably some chemicals, some consumables, excuse me. Yeah. Good. Those are all really important. And we saw starting before. And then on the opposite side, this is a little tricky because you at your facility might not have emissions, but somewhere across the life cycle, emissions might occur. So what are some of the emissions that could occur in the facility or elsewhere? Things released to the environment. Wastewater. Good. Greenhouse gases, yep. You're burning fuel. Air pollutants, yep. Water pollution, yep.
Yes.
VOC is a nice one. VOCs.
Are you, when you say emissions, are you also including? Are you saying release?
Yes, thank you for that clarification.
There are a lot of emissions coming, but I think you're meaning release, right?
May I ask how you, the questions releases versus emissions? How would you define the
Waste, and solids, those types of things. I think we heard, water, but then we heard multiple.
Yes.
Emissions.
So
that are more gaseous or.
Correct. Thank you for clarifying. This is a question of domain that you're used to. That would be, and I could do a good job of clarifying this. I see focuses on modeling what happens inside the technosphere, and then anything that leaves the technosphere, as it's called, enters the environment, enters the ecosphere. So if I emit, sorry, if I burn a fuel in some sort of combustion engine, then particulates, carbon could be released or emitted to the atmosphere. It's left my engineered system once I've done it.
But you also have potentially a solid waste that may be within that engine that you may have to dispose of
Perfect.
as a solid, and so that's why I'm.
Perfect. Yes.
You have other pieces.
Correct. So if you have a solid waste that you dispose of properly, say to a hazardous waste facility, it's still inside an engineered system. It has not entered the environment, and that would not count as a release or emission. I think I get to settle that, but for those that use the two terms differently, I'm trying to say any sort of loss of the material to that environment has not occurred when you're sending it to a waste facility, unless there's a spill. There are the models to say, 1,000 years from now, is the landfill going to rupture and I'm going to have this material come out? That's a whole nother question, but great clarification. I'm talking about materials that have left an engineered system when I say emissions or releases. Noise. That's a great one, and it's worth saying that noise is also not yet well captured in LCA, but is also being worked on. Fantastic. And that one's tricky because we don't have a massive noise, but we have certainly energy there. Fantastic. It's a great one for long-term healthcare costs. Okay. Any others? Heat. Very nice. Heat.
Byproducts in the chemical topics.
Byproducts, right. And this gets back to your question about how do you handle them? Are they moving through the stack and scrub them out, or did I capture them? And what am I doing with them next?
But
Right.
that could be a process question, like, are you more efficient in one mechanism versus another? And so that is something that you look at. Is this actually intended to capture those waste or those products versus this system just doesn't? We know that.
Yeah.
Part of your study, the problem thing.
Fantastic. So just for the recording purposes here, the question of how you deal with byproducts could be part of the analysis. That could be the question you're trying to ask. Is it worth, not is it worth, but what are the benefits of capturing and dealing with waste in this manner versus that manner? Excellent job. So now I think we've almost, we got everything pretty much. So in general, when you're asking these sorts of questions in this sort of technical environment that you all tend to work in, this is kind of, you should have all these. It would be kind of odd if you're missing a majority of these, but we'll always have energy, we'll always have materials or consumables, chemicals, and then we have things that leave the system in a variety of ways. And it depends how we handle those when they actually leave the system. Okay. So this is a great time now to, having talked about those and your examples, I think we can do another discussion. Good. To think about the different kinds of costs. And I think I didn't clarify this well. Michael got to this point. The gray items are ones that you could estimate based on your knowledge of a system. They are direct, when we're talking about cost, these are dollar amounts that you know, I pay this much for electricity, I'll pay this much for healthcare, et cetera. The blue one is coming from those far field emissions that the LCA has captured, and LCA can give you damages in terms of midpoints and endpoints and dollars. We didn't talk about that very much. I think for that's sufficient. We'll see the numbers a little bit later, but the greens are ones that you would estimate directly using the accounting tools and maybe some probabilistic approaches for the long term. The blues are ones that you would not estimate in terms of money, rather you would estimate in terms of environmental impacts through the DIO. And those we can translate to money as well. So let's have another 2-minute discussion and try to break up the costs you might see for your systems into direct, indirect, contingent, which is the probabilistic, and then finally the external, which are the far field emissions that are turned into impacts in LCA. So please, among your tables, let's see if we can get a few examples of each of those, and we'll do 2 minutes and then we'll come back together.
Yeah. With respect to the waste. In the inventory. Still. Waste.
Yeah, it's part of the inventory. It's part of the inventory.
So I think. So sorry. So we can finish on time. Lovely, okay. Some fun. I can share. Time, please. Okay. All right, let's go through the tables again, and maybe you can give an example. Let's see if we can get one of you. So if you're the last table, you may have to fill in the host one. Give us an example of the costs you thought of. So one piece of equipment, which is the basic equipment, and another one is retrofitted, so it has added equipment. Okay. So there's a difference in equipment cost. Great. Now, if you do the retrofit yourself, then it's labor and material to build that retrofit. Okay. But then also the raw material consumption, which is the foam, is different. The more complicated system, retrofitted system, uses less to achieve the same amount of time to put a fire out. Okay. And
proportionate to the amount of reduction in film use, there's a reduction in wastewater. But we couldn't figure out whether the wastewater we considered indirect or direct cost.
So it depends on your entity, but oftentimes what we've seen at the Defense Department is that it's an indirect cost because as the process owner, you may not necessarily own the wastewater treatment plant. And so it does depend on the facility, but we've often seen that would be paid for by someone else. In that case, that would be an indirect internal cost. Someone else in your organization has a budget to pay for that item.
Great. Thank you very much.
We try to add some indirect costs to that, things like management profit, CUI training, time, safety, security, various things that can be attributed to a specific project.
Yeah, that's a great example. And I think any project will have those, the safety trainings, et cetera, will have to be done, but the project itself is not paying for them. Yeah. Yes.
So we had a lot of the same ones for direct and indirect, but a couple of the contingent ones we were thinking of was pollution cleanup and material toxicity, any lasting effects from working with hazardous materials. And then one question we had was on whether or not supply chain, I know that's a big term, but there's a lot of things that come with that, if that could be considered implications for a contingent cost within a process.
Okay, first of all, so great job with identifying some contingent costs to clean up. I think you said issues associated with toxicity, which could be healthcare, could be remediation. So supply chain, did you catch that, or can you restate that?
I'm happy to.
Yeah.
I think the question was, are there costs from the supply chain that can be quantified via this process and where would they fall?
Mhm.
Right. And I'd say probably in a couple of different areas. One, the external cost does incorporate upstream, what we'll call damages to the environment from the supply chain. So that is a supply chain cost. In the internal costs, oftentimes it's considered that a cost of procurement includes the cost of the supply chain. However, in the contingent cost category, there may be a probability of a supply disruption depending on the issue that you're working on. And so it would fall in that category. So we have supply chain issues that are in the direct cost or the internal costs in the direct side, contingent bucket, and external costs. So it's all around us.
Mhm.
Great answer. I would just add that the question about reshoring is certainly related to that probability of disruption, which you could include in an analysis saying this system is US, that one's not. But let's have this question first. Okay.
Add to that, because in my area of research, I also look at a couple of things, the hidden cost of quality.
Okay.
And maybe additional steps would be needed for compliance.
Okay.
And then the governance to go with that.
Okay.
And then the other points, it would be from the brand. Is it going to damage the company's brand?
Okay. Yeah. Great. That's something we don't have to think about. But the cost of quality, I think in the context of LCA is often comes to bear on the functional unit. How many, if I have a low quality product, I might have to buy more of them to achieve the same function as a high quality product. And that may not be what you're saying, but it's the kind of thing you want to think about.
It has effect on the reliability.
Yeah.
It's definitely.
Yeah, great addition. Okay.
Yeah, so we were looking at coatings, and so, the direct internal cost would be the cost of the materials themselves, the cost to store them, the cost to, actually procure and get them to your warehouse or the facility is.
Yeah.
Indirect internal costs, we kind of came up with if you need a clean room or any sort of specific facility for the processing of those materials, or the equipment for the personnel to protect them from the processes.
Yeah.
And then contingent internal costs were, cost of cleanup if there was a spill on the site, or even just trying to capture any residual effects from the process that you're looking at.
Yeah.
Yep.
Great. Those are great examples.
Logistics. Yeah. So I think pretty much everybody has kind of captured all the stuff that we came up with. The few extra things that we were thinking about were changes in workforce training and development. So we're going from sort of this casting, activity to, managing, software and the 3D printer and all that. And, is that a contingency? I mean, we have labor costs, which would be direct costs, but there's also this training kind of potential deficit that could be a contingent cost.
Right. Yeah.
What was the other one?
An example of that we've included in analyses before are training costs or even costs related to, say, donning and doffing. A process may require more PPE than another, and we have often included those in indirect internal costs. However, I could see where if it's not for sure the case that there may be additional training required, then that might fall into the contingent bucket.
But if you are training new generation of workers to do the 3D printing of stuff, that means people who have been doing casting and doing technical assembly, they are no longer going to be needed if this thing works. So that is the external cost, right? That's a social cost. That workforce have to be retrained to do.
That's a great philosophical question.
You should first just think all different answers. I'm just adding complexity. You stumped us.
No, that's exactly, but that's the way you want to think. Who's going to weigh the cost? What's going to happen to those workers? And it may be a function of your agency, in your particular realm, how important that is to think about. Can you retrain them within the agency and maybe save money on hiring? I don't know. They could go a lot of different ways, but you're exactly right. Presumably those folks would have other skills they could use elsewhere, but that's a great question. And that's kind of a impact of technology that we don't talk about very much.
One thing I don't think people have mentioned, but first on that point with the casting versus the additive is a little unrelated. There's not that many people who do castings, especially in the US. So that wouldn't be a problem. One reason why casting is so expensive is because China does most of the casting. So if we do need to do castings in the States, there's not enough of it. So it's that, yes, it's a cost. They're not as in demand, but I don't know in that case. But related more to this question, we talked about some of the health implications of repairing at the point of need, as opposed to having a centralized place where they manufacture the components. You're having a lot more people exposed to not so great substances when doing that repair and being exposed to that raw material.
Okay,
so
excellent. And that's exactly the kind of question that this is intended to elicit, such that if you're suggesting that point of repair makes sense, you can anticipate there are these additional potential health issues. And you could either say it's in the scheme of things, it's okay, we can compensate those folks for those health issues, or it's worth figuring out a way to minimize that exposure and keep them both equal in terms of health. But that's exactly the kind of question. That's fantastic. Yes.
I wonder if you could dig a little deeper into the issue of PPE. It seems to me that if a worker can't go into the production unit with PPE on, it's a direct cost. And further, the time spends down on nothing, it's a cost directly related to production. So I'm a little puzzled by the characterization of indirect.
No, thanks for that. And again, the direct internal costs and the indirect internal costs, it's just a function of who owns that budget. It may or may not be the owner of the process line. So they are most definitely internal costs. So that could change depending on the scenario.
Great.
Okay, another philosophical question. Sorry, since we're talking about LCA and so many different diverse research problems, depending on what is the technology or research question you are trying to answer? I'm an academic, so there are also benefits that come out while you are developing the technology, either it fails or succeed. We are often just talking about cost. Is there a benefit that subsidizes any of these things? I'll give you an example. Two graduate students worked 3 years to develop a certain technology. It went into TRL 4 and it failed. Okay. There's a cost associated with it. There is a huge surplus you got. You have 2 PhDs on developing certain technology. That brings a workforce development aspect to it. So
Yes, that's very true. I think one point, first of all, we often talk in terms of costs and impacts. We don't talk in terms of benefits. And if you're able to talk about the processes you're proposing, the systems you're proposing in terms of benefits, obviously it's great in terms of communication. But that sort of question, I think, is good. That needs to happen. That's uncontrollable. Sometimes that's just the way that the research goes. And so this analysis wouldn't be so much applied to a system that's poorly understood. So in that case, you could argue that the graduate students are working in a poorly understood system, and therefore there's a potential for failure. This would be more something that the graduate students could have done early on at tier 1, 2, 3 to understand what would happen if the system was actually produced and implemented. So I think that I welcome other thoughts. I don't think that I say we used to describe that sort of story of education.
Well, and I'm happy to jump into oftentimes we had a good example last year of TNO, one of the funded projects, it was sort of the ESTCP, where they actually conducted LCA at multiple stages in their project. And what they did was at each stage, they began with a screening level analysis, and then they used that information to inform the development of the next step of the system. And then when they got further along, they did another broader analysis, and then that inform further design decisions, but they were conducting these analysis periodically to help inform future decisions. And then ultimately, this information should help with more sustainable design. I just want to say on the cost and benefits side that although this does include the benefits of education, if you were to use a benefit cost analysis methodology in accordance with the Office of Management and Budget Circular A94 for the guidance for benefit cost analysis, the external costs would fall on the benefit side of the ledger. It's not comprehensive from a benefit cost analysis framework, but just to give you an idea that those would be classified as benefits in that framework.
I'm just going to add, I'm Carrie Meyer, work with DoD. So Michael works really closely with some of these noblest people, and John. I think it really depends on the framework in which you're working in. So sometimes you're trying to address a logistic issue and a problem. So you're trying to solve something, but you may actually start with an environmental issue that you're trying to solve as well. So depending on the type of question that you're asking in the first place and how the technology is helping to address that particular issue, you may have different mechanisms and different columns. And it doesn't necessarily matter whether or not you put it in one column or the other for your particular question, because you're looking at a baseline and you're looking at the secondary or tertiary, the effects on how you're comparing to that particular baseline. So however you set up the problem, as long as you follow that 5-phase framework and you're using that consistent method through those comparative analyses, then you're coming up with a real answer. The other thing that you need to keep in mind is if you're looking at that environmental impact, you might be looking at avoided cost. So if you're looking at a liability or a cleanup issue or a problem that you're trying to improve upon, then you're dealing with, and there's a cost associated with
that disposal mechanism or the health effects or some other long-term. And so you may be calculating an avoided cost. So I don't think we've talked about that yet. Okay.
Yes, great point. So when you do those contingent costs and you have two systems, you can present the difference as an avoided cost. Yeah. Okay. So not too many people talked about the external costs. That's what we're going to calculate with the scoring factors, which is our next thing to do. So really good ideas. I think we probably got most of these. Yeah. And PPE could fall, depending on your system, some of these could move around. It depends on specifics. It depends on budgets. But in general, the sort of LC thinking is getting us towards the full picture. What's happening long term? What if we don't do this? What's going to happen to the workers, et cetera? Okay. So now we are going to see how this works as a backup, but I'm going to show you an Excel file that is available to you right now on the agenda. And we will populate it a little bit. You're welcome to pull out your computers at your table or just kind of follow along as we go. So I hopefully will take this, go on rogue. And now I can share, right? I need to get the other participant not to share. Is that this computer? Yep. Yep, I got it. Stop. Okay. Okay. Great. So at the session description, there is a Excel file that takes the scoring factors that you have seen the link for on the Denix website and just adds kind of a layer of interactivity. This is not meant for production use. This is just an interactive file for you to use. It has some kind of sequential data validation if you use Excel, and it's filtering hundreds of thousands of rows, so it's a little slow. So this is just a way for us right now to interact with the scoring factors. So the scoring factors, as I will show you now on one of these computers. Yes. Those are good. The scoring factors, which come directly from the Denix website, are a beautiful table that you probably can't read. What is it? 300,000, almost 400,000 rows of cost of spend data, of mass emissions in various locations, and it connects them to impacts to human health, impacts to ecosystem quality, et cetera. So if you're using this file now or later, there's a tab called User Table. And in this table, we have an example of the zinc nickel plating line that we talked about. So this is the slide that you saw before, where we had some quantities of processed chemicals, et cetera. And the DIO has a lot of specifiers. So we have to specify, is it input? Is it supply chain? Is it a chemical material? Which economic sector is it from? Where is it emitted? Is there any specific information about the compartment? And finally, how much did we buy of that thing, or how much did we release or emit? So in this case, this is the zinc nickel example, hydrochloric acid. We have bought $900 of this. And here's the beautiful thing. This is as I said, all the environmental work that goes into these scoring factors comes out in this way. If we keep scrolling to the right, here are the results from the DIO. So now we know a climate change impact from that $900 of hydrochloric acid, accounting for general US transport. We know respiratory inorganics, et cetera, carcinogens. And these are all, we can talk about midpoint, endpoint if anyone has questions, but really what we want to focus on the endpoint. So here's a climate change impact. Here's a human health impact. Here's an environmental quality impact. And finally, we can add all those together in the valuation step that Michael talked about to turn it into external cost, and that was the blue right-hand cost that was very hard to come up with in these examples. This has, so $900 of hydrochloric acid in the US is $220 of total external cost. It's a really powerful tool. It's very interesting, and we really hope that you'll use it and ask questions and think about ways to apply it to your problems. So I apologize that it's so small. I'll make it a little bigger. Let's get another example of something that was, I guess, actually in the zinc nickel line, we don't have any direct releases to the environment. We don't have any emissions that leave the stack without being scrubbed out. But just to show another example, from that zinc nickel line, we're buying electricity. Again, we have to specify all these pieces. It's an energy use average. It's in Florida, et cetera, et cetera. We use 30 megajoules, and we could scroll all the way across and find the impacts associated with that. So this file furthermore goes down at the bottom and then sums up the endpoint for the three examples that we've got here. And the other option A and option B are just there for you to look at. So what I'm going to do is delete option A and option B. We'll go around and have people draw some number of megajoules or whatever. We'll try and populate it. You're welcome to follow along and do it yourself. If you need the website, let us know. But then you can just compare the zinc nickel plating line to our Frankenstein example. And hopefully seeing this in action will help you understand how to use these scoring factors. Sound good? Okay. So just before I delete them, these demos, look, we've got items purchased from the U.S. economy. Yeah, we've got some energy used here, natural gas combustion. We've got truck transport, and then we've got inputs of raw materials: cadmium, water, coal. This particular example has also some crop production, and then down the bottom we have releases of arsenic. We have use of water, and we have release of sound. I will point out, as I said, you mentioned noise. The sound, the noise doesn't have any characterization yet. So if we scroll all the way across, there's no impact associated with that yet, but there will be in the future. So it's good to, again, think of all the things that your system uses, things that your system releases, and put them in here when you do this. And so actually we could just add another row here. Let's do that. So let's have our Frankenstein. All right, so this will be table number one. We can give everyone a moment to think about this if you like. I don't know, not too many people have this pulled up on their laptop, so you'll have to watch me do it. So maybe for the examples that we talked about, let's take another 1 or 2 minutes to think about one specific thing that you might purchase. And then if you can, one specific thing that would count as a release, as in we're these aren't great examples, but you know, we happen to be releasing arsenic to some water. So if your system releases arsenic to water, you should redesign it, but you get the idea. And again, they can just be fun examples. So see if you can think of something you buy. That one's mandatory. If you can also think of something that might come out of your effluent pipe or come out of a stack, you get bonus points. Okay. Byproducts. Okay, so 1 or 2 minutes at your table, please come up with something, and then we'll put it in here and we'll compare it to the other examples. So something you buy, something you release, so a byproduct.
Yeah.
Just to get the flights on time at 7. Specifically, we have further questions. Is it okay? So we're going to go tables and again, looking for something that your system needs to operate. And I'll see if I can find it in the DLO.
Mike brought up a good one. DOCs likely would be a problem because you have to remove the paint and then repaint it. So
you're talking about VOCs as you're purchasing as a reagent.
yes.
No, I mean, you're adding on the new coating, so you're repairing a panel, aircraft panel. And so, you strip it off, but then you're reapplying. And so you have DOCs that are being emitted.
Okay, so this one
process.
we could we'll do this one actually both ways if I can find them in here. So you're buying the paint.
Yeah.
And then you're losing some fraction of it. You're losing some VOCs at the stack or up. Yeah.
Just into the air.
Just in the air. Okay.
The usage of that material has to be tracked.
Okay. So again, if you can't see, let me know.
Which solvent, Joe?
Which solvent? I'll see what I'm gonna. So we talked about the fact that the D.
You're big. We thought the same thing.
No, I'm not able to. Okay, so my mouse is. Okay, so the DIA operates, as we said, it has US economic information at the economic sector level, plus some DoD specific processes. This is going to be a little bit disappointing. Let's see, we're going to go for solvents. Do we have solvents? Nope. What would it be? Not going to be paint. Oh, it is. Okay. So again, by going through here saying an input, supply chain, chemicals, I found a US economic sector, which is paint and coating manufacturing. Then that's right. Thank you. The numbers there are 6-digit mix codes. So now I should be able to come through and choose. If I can calculate. So no, it is. This is where the filterings that are slow. This is going to be. Come on. Okay. Let's do this one more time. All right, it's
Can you leave a comment blank and it's still work?
no, you can't, unfortunately, the way I set it up. But what did I miss? Oh, I can try. I don't think it's gonna work. Okay, what we're gonna have to do is we can do these first ones again, so let's just skip them in here and then I will try to figure out as we break what's going on, and those who want to stick around can see the results. So we also have a release here, and you saw the ketone. About diethyl ketone, there it is. And let's see if I can get this row to work. You can see at the bottom, it's calculating. It takes a few minutes. Again, filtering this amount of data in Excel is not wise. Okay. So I will fix this so that we can see the results. But now we've got both the purchase of the paint and the release of some quantity. We haven't done the quantities, but I'll put those in a minute. Okay. Next table, please. Let's get something you purchased or something that's you're releasing a byproduct.
We purchased 3 tons of titanium oxide.
All right, perfect. There we go. 3 tons titanium dioxide. Let's see if we have titanium. We may not have that resolution. So I think we're going to have to go for inorganics. And this is something that often happens when we're operating at sector level. You're going to say titanium or so.
Tungsten.
Sorry?
Try tungsten.
I think because what
chemicals in there, I mean, there are some.
Metals, that's right, there is a metals, isn't there? No, there was metal.
Metal.
So it's not just the mining, it's the actual. It's the actual
primary smelting. What's the one below that?
I think this is great. This is great. You're seeing it live. But again, US economic sectors, even at the 6-digit makes level, are pretty close. So this is a case where if you really wanted to model tungsten, which you do, you could look up how the UCIO was modeling inorganics, and you could see if there would be differences for tungsten. You could also go find from some of the resources we mentioned, other specific data for tungsten from US lifecycle inventory databases.
So
again, this kind of depends on the level of detail that you want.
We should probably do the one that says, what is that, non-ferrous metal? Or does that say except copper?
It does. We're going to choose one for now. Yeah, we're going to pick one. The
most expensive one.
The most expensive. I like it. I like it.
Do you want an output?
Well, sure. If you got one.
We had something terribly go wrong, so we made a whole bunch of ammonia gas.
Ooh. And a great question. A great question. I have Tyler still here, but someone asked about dynamic versus static LCA. So if you're always producing gas, then that would definitely go in here. If it's an occasional thing or a one-time thing, you might exclude, you might put in the contingent costs. So lots of interesting questions about how that works. But we have a release. It's going to be chemicals, and let's see if we can find ammonia. Yes. And then I'll fill in the rest in a minute. Thank you so much. Great. Next table, please.
Oh, you're gonna change it up. What about
like Tyvek suits for Wellington?
Wow.
And those are sometimes when you say it's waste generation too.
Okay, great. Tyvek suits. What is it? I think this might be Tyvek is not going to be there. Yeah, wow.
Maybe PPG.
Let's go for textiles. Thank you. Somebody saved me. Give them. All right, and now we have a waste. So in this case, It depends. We talked about this earlier. What are you doing with the Tyvek suits when you're done with them? Out the back door or to the landfill? That's the right answer. So in this case, the way that this is set up, you're actually procuring a service, which is the hazardous waste disposal. So it doesn't actually count as a release. So this would, but it's a wonderful example. There would be an input, supply chain, and now we should have a choice for other costs, and it's waste something, right? Waste management and remediation. Again, pretty close, but that's where landfills fall.
So I think with given time, we should.
Okay. So you mean skip the other three?
Yeah.
Yeah, okay. Michael's right. We're gonna have to save your examples for next year. So why don't we wrap up with questions? And then I'll get this working in just a second. Anybody who wants to come and see what the results look like, to see those numbers. We're looking, if there's any problem with the file, we'll fix it so that when you download yours, it'll work. So questions now, no more releases. Yes.
So one of the questions I have is, what's the typical cost we should propose to SERDP or ESTCP for doing these analyses of SERDP project scale versus ESTCP? SERDP being TRA 2 or something like that. ESTCP being 5 or 6 maybe. How much cost you think is typical? Maybe Mobilis can estimate that. A typical cost for conducting an analysis. Yeah, that's a good question. I think we might have to think on that one and work with the program office on guidance for how to include that in proposals for statements of need and et cetera. So that's a good question. Don't have an answer right now, but especially as we think about the toolkit, that's something we should probably respond to in the frequently asked questions.
Sure. I have a proposal due on December 15th.
Yeah, we're thinking about that in expedient fashion.
Speaking of timeframes, Emma mentioned that it wasn't publicly available yet. What's the timeframe for the website to go public?
It's undergoing to review, we still has a few, we're finalizing the documents and posting next few months. So it's not live that.
Okay. To respond for responses in the next few months, the website should be online.
Thanks. This is awesome. Can you give a quick overview of the data sources that went into this?
Yeah, that's a wonderful question and something I love to talk about. I will go. Okay, I'm going to go back. I think we have it on this presentation. So there are a number of data sources that are into the defense input output tool. The engine or the DIO tool is the United States Environmental Extended Input Output model that's produced by Environmental Protection Agency's Office of Research and Development. So we've collaborated over a number of years with EPA, RD, and development of agencies use DIO. And with DIO, there's a number of data sources, including the United States greenhouse gas inventory and toxic waste inventories. Also, within the model, there's information from which is a tool that's developed by the Department of Energy and Oregon National Lab. It includes a lot of information around transportation and biofuels. I'm going to say a number of their activities. And we also have all our information from the Bureau of Economic Analysis, BEA, and BEA has underlying economic data, a series of input-output tables that allows us to understand the intersection of flows between sectors. So it will give us a supply chain emissions understanding, and that's a best practice in the modeling community. And that's not a comprehensive listing of the sources. I am happy to share the final report that we developed together with EPA on DIO, and it's a 100-page report with lots of information about this. I'm happy to share.
The facility side, there's been numerous LCA tools, that have come out, over the past decade, and even to Federal Highway Administration under there's an LCA tool. I think impact estimator for building, an eco calculator. Another one is it's a environmental building for environmental and economic stability. Anyway, on these though too, the greatest Achilles heel of them is the LCI, right? So with that, initially it's very limited. I think it's probably over the years too, has expanded. Especially too, when you're talking about then DoD installations, with some of the unique aspects too, from a facility standpoint, on LCIs. But then that leads into the EPDs, right? The investment product documents, which, most companies now too, that are really going green on, green materials, are endorsing, basically showing all of the embodied carbon, embodied energy, and it's in the EPDs. So that's also too, feeding into, to LCI. So just thought I'd mention that.
I agree entirely. And one of the things that was mentioned earlier was the federal LCA Commons, which is an interagency effort to align LCA activities across the United States government. These are focused on U.S. LCA activities. There's also a number of LCA efforts going on in the European Union related to product environment footprints. Environmental product declarations have specific approaches to do simplified LCAs for specific product categories. And but the underlying data that can be used in each one of these subfields can vary slightly, or there will be increased resolution in certain sectors, for example, federal highways. With their tool, but that's part of the reason for the interagency efforts to try to align modeling frameworks. So there's interoperability, data interoperability between the tools. So that's an ongoing effort in the modeling community to improve that. Okay. I think we're actually over time. So I want to thank you all so much for attending today, and happy to stay a little bit after and answer additional questions. We really appreciate your time today, and hopefully you got something out of it. And we look forward to seeing a lot more LCOs as part of SERDP and ESTCP projects.
And before you go, I fixed the data validation problem. So I just want you to know that at the screening level, as we just quickly went down the road, we got 2 tons of this, 2 tons of that. We now have results in terms of climate change, et cetera. Now, these are not good results because we use chemicals instead of tungsten, but you can very quickly, get a screening level result. So Sorry, thank you so much for your time and participation. It was fun. So I hope it's helpful, and please contact Michael and Emma with questions about the toolkit, et cetera. We look forward to, as Michael said, seeing your work. Thank you.